In many ways, fashion has always been technology. Cutting a piece of cloth and turning it into something that can function on such a dynamic and expressive system as the body is an extraordinary technological feat. Technology has and continues to move ahead in leaps and bounds, and I think that's a very exciting thing for fashion. Many people have different ideas about what wearable technology is, but I like to think about it as interactively responsive garments and interfaces. As technologies advance and as they're explored with, they can extend our ability to communicate with each other. They can extend our knowledge about ourselves and what's going on with our bodies. They can communicate that knowledge to others if we want it to. Wearable technology occurs in two spaces at the moment. We have artists and designers doing a lot of highly poetic explorations that aren't able to be brought to market. But then we have examples of engineering-driven wearable technologies that are brought to market. Helen Story and Tony Ryan, for example, are major leaders. They're champions in many ways of investigating how scientists and artists and designers can collaborate fruitfully to really innovate and look at how these innovations can play out in everyday life, so become products. Susan Lee, with her BioCouture project, is really looking directly at synthetic biology, biological systems to create new materials. Pauline van Dongen is in many regards a younger researcher, and she's trained as a fashion designer, and she's working with scientists to try to refine ways that wearable technologies can be developed in a fashion context and actually brought to market, and this is one of the biggest struggles. We can see around us with some of the sporting applications of wearable technologies. We see microcontrollers paired with the body that can give you data about how you're running or how you're exercising or how your body is responding to situations. But as technology is evolving, we're beginning to see applications of the biosciences and the life sciences and the material sciences. We can 3D print DNA. How could that manifest itself in a wearable technology? There's a compromise between what's currently possible and what is desired in order to produce things at the moment, and hopefully that compromise will be less towards the engineering and a bit more towards the expressive capabilities and extraordinary potential of wearables as we move forward.
Since 2001, the World Economic Forum's Networked Readiness Index has assessed the ability of countries worldwide to make the best use of information and communication technologies. This assessment is based on the performance in four main areas. The environment component measures the quality of the regulatory and business environment. Readiness measures affordability, the quality of digital infrastructure, and a population's preparedness to use technology. Usage measures the levels of technological diffusion among individuals, businesses, and the government. And impacts measures information and communication technologies' social and economic impacts. In the 2015 edition, Singapore replaces Finland at the top of the ranking. Not surprisingly, high-income economies continue to dominate, taking the top places, with performance of countries largely mirroring their position on the development ladder. Sub-Saharan Africa still faces serious challenges, with all but one country appearing in the bottom half of the table, the only exception being Mauritius at 45th. The index also highlights a number of success stories in the Gulf region and Central America, and in the Caucasus, Armenia is the country that made the most progress since 2012. The performance of the three Baltic countries is particularly remarkable, with Estonia preceding Belgium and Ireland, amongst others. The impact of information and communication technologies goes far beyond productivity gains. They are catalysts of economic and social transformation. They enhance connectivity, kickstart business, create employment opportunities, and change the ways in which people communicate and interact. Yet it is only through widespread usage of information and communication technologies that real change can be made. Information and communication technologies are not as accessible or as fast-spreading as many believe, with some 60% of the global population still not online and some 450 million people out of reach of a mobile network. So, how can we provide universal, affordable and fast access to bridge the digital divide? Policymakers and their partners must adopt a long-term perspective to address these challenges. This requires smart, long-term investments in digital infrastructure and education, as well as sound regulations that encourage competition, innovation, and private investment. Information and communication technologies hold the potential to transform our lives. Let's turn this potential into a reality.